at some linear equations real quick and some of the smaller nuances that exist with some of them. We're not going to dive too deep into some of the background of how to create a linear equation. I'm going to run through that example fairly quickly. And I'm going to run through this idea of what is a coordinate grid very quickly. And if you need more information on that, I encourage you to reach out, find other videos, or just send me a comment and asking for additional videos on this topic in terms, or other subtopics as we go through those, and I can explain those more in detail. This is primarily kind of an overview with a focus on parallel and perpendicularness. So what I have here is a coordinate grid. So I'm starting over here, and I have my coordinate grid, and also you can find it under a Cartesian grid. But normally we talk about it being a coordinate grid because the idea is that each point represents a coordinate, an x coordinate and a y coordinate, so it tells you how far right, left, up, down. Here we're moving. We label this first quadrant. In the upper right is your first, second, third, fourth. It goes counterclockwise, which may seem kind of backwards or weird. That's the way it's set up. So what I have here are 2 points, 2, 1, and 1, -4. Incidentally, in the second quadrant, the points are negative x's and positive y's, and in the third quadrant they are negative x's and negative y's, and then you get to the fourth quadrant and it's positive x's and negative y's. So above the x-axis, below the x-axis are positive y's and negative y's respectively, and the same thing with left and right to the y-axis for the x's. So what can we do with this? Well, we have these points here, and we can do stuff with them. Why do we want to do stuff? Because we can determine information, all sorts of information, the whole application process. So this is even a different discussion than what we're doing right here. Here we're just talking about the mechanics. But a application would be if you're wanting to build a house on a property, you need to identify locations. Those are going to be coordinates that you're going to be working with. If you're talking about using a map to get from point A to point B, point A, point B, how do you get there? Straight line. How can we determine those locations? But here what we're going to focus on is just kind of mechanical aspects of things, starting off with this slope. So in a whole other video I mentioned that the idea of slope doesn't really matter whether 2's come first or the 1's come first. What matters is that you have the 2's lined up vertically and you have the 1's lined up vertically. Beyond that it doesn't matter because I don't have either of these two designated as 1 or 2. So that doesn't matter. Pick one. Alright, so I find my slope. And my slope here would be 1 minus -4 over 2 minus 1, which gives us 5 over 2. No, it doesn't. It gives us 5 over 1. Alright? So, what can we do with that? Well, what it tells us is that if we go up 5 units and over to the right 1 unit, and up 5 and over 1, we're going to stay on that line. It tells us the slope. It tells us how much this line is changing by and what direction it's changing by. It's increasing in the y direction by 5. I said up, but it's not really up though. Changing in the x direction by 1, positive 1. So that tells us how we can find the next point. We could also go left 1, right, and then in the y direction by 5, downward 5, if you again, downward, right? So that gives us a way to get to the next point. What else can we do? We can go use our point slope form here. Y minus, it doesn't really matter which point we use. 1 equals 5 over 1, and then x minus 2. Or you could do y is minus 4, negative 4 actually, equals 5 over 1 again, and x minus 1. And both of those are going to give you the exact same. If you were to simplify them, they'd both give you the same thing. Like distribute your 5 through, you get 5x, or 5 over 1, minus, that's 5 times 1, which is 5, negative 5. And then you subtract 5 from both sides, you get negative 9. Well, in this one, the same thing. Distribute your 5 through, that would give you negative 10, plus 1 would give you negative 9 again. So they give you the same equation. Now, what does that mean? It means that this line right here would cross through, now I didn't draw it very well, it would cross through right here at negative 9. So this is not drawn to scale by any means. Right? So just kind of pretend for a second, right? What else does that mean? Well, the other thing that means is that I could write some other equation. Y is equal to 5x plus 1, which would be right there, crossing through at 1. So this would be equation 2, if you will. So here I have equation 1, there's equation 2. And the thing that we now know, I didn't draw this very well, but the thing I now know is that these two lines are what we call parallel, which is a whole another discussion of itself, I guess. But the gist of it is that it means that these two lines stay the same distance apart at all points. So if I pick any 2 points, they're going to be the same distance as any other 2 points if you're going straight across from one line to the other. I didn't draw it that way, but pretend, right? So this is a linear equation of the slope of 5. This is a linear equation of the slope of 5. We would have these like train tracks. They'd be parallel to each other at all times. And we know they're parallel, well, because if we were to measure this out properly on a good coordinate plane, we would see they stay the same distance apart at all points. Mechanically, we know that's true because the slope of 5 and the slope is 5, which brings us to this idea, is it means they have the same slope, or equal slopes. All right? Now what else can we do? Well, the other thing that we can do is we can take this slope, which again is actually 5 over 1, and we can do something to it. Let's rewrite it as, let's say it's y is equal to negative 1 over 5 x. This time let's use either one of these. Let's say plus 1. What does that mean? Well, okay, so let's just think about what does it mean for what is slope, right? So we go down 1, 1, 2, 3, 4, 5, and go over 5. So it's actually, we have us doing, I didn't draw this to scale, but we have us doing this. Alright? I didn't, again, not draw the scale very well at all. But that's, the idea behind it is that we would create a line that in this case is actually perpendicular to that other line. So when we say perpendicular, it means if the slopes have the negative of each other and flipped, they're called a negative reciprocal, right? So we went from 5 over 1 to 1 over 5, and went from positive to negative. Doesn't matter which one's positive or which is negative, you just change them. And then if you were to do this a second time, you create another line, say right there, you could actually create something with 2 sets of parallel lines, which makes it a parallelogram, and then the angles would be right angles, and that makes it a rectangle. So it's actually kind of useful, like going back to the idea of trying to identify the foundation of a home. A lot of that is done very, very precisely these days. If you're off just by a little bit, you're building a home on someone else's land, which actually does happen when people aren't paying attention. It has to do with this idea of like, where are we placing it? Where's the plot of land? How are we getting from point A to point B? Like if we wanted to go straight here, we wanted to go from that spot to that spot, from A, we'll call that B, C, we'll call that point D right there. What if there's a lake in the middle of this? How do you get over there? We just follow the lake, right? Another option was just say we're going to build a road. Road this way, road that way, here, there. So there are lots of applications to this idea and why it's useful to us. One of the things we can also do with this is identify this to build rectangles. So think about this and work on this. Reach out with additional questions and comments and other videos or details that you need to be answered for this. All right? Take care.